All right, welcome everybody. My name is Lucian Fogoros. I'm the co-founder of IoT World, and on behalf of our sponsor, Hitachi Vantara, I want to thank you for joining this session and supporting IoT World Days. Thank you to Bill Schmarzo and Steve Garbrecht for joining us today. Steve Garbrecht will be our moderator, our MC. So just a reminder to post your question in the Q&A. Steve, welcome, and give us a few words about yourself.
Hi, thanks, Lucian. My name is Steve Garbrecht. I'm the Director of Solution Marketing at Hitachi Vantara for Manufacturing Solutions. Want to welcome everybody. Thank you so much for coming today. Today, especially with the pandemic going on and all the things that are going on in the world, it's really important for manufacturers to leverage every asset they possibly can. And one big asset that really goes unlooked is big data and data in general in manufacturing across the business. As part of the presentation today, Bill Schmarzo, who's a resident expert in big data. In fact, as part of the session today, if you ask questions in the Q&A, you'll be placed in a pool to get his latest book, The Art of Thinking Like a Data Scientist. Bill has a lot of experience. He's the author of Big Data, Understanding How Data Powers Big Business, and also another book, Big Data MBA, Driving Business Strategies with Data Science. As Hitachi Vantara's Chief Innovation Officer, Bill guides the technology strategy for IoT and analytics. With his breadth of experience delivering advanced analytic solutions, Bill brings a balanced approach regarding data and analytic capabilities that drive business and operational outcomes. He's also a University of San Francisco School of Management Executive Fellow and an honorary professor at the School of Business and Economics at the National University of Ireland at Galway. Bill holds a master's in business administration from the University of Iowa and a Bachelor of Science degree in mathematics, computer science, and business administration from COE College. Ladies and gentlemen, please welcome Bill Schmarzo.
Thanks, Steve. Let's dive right into this thing. And this is going to be a very content-heavy 30 minutes. So bring a notebook. There is going to be homework assignments at the end, and I wouldn't be a professor if I didn't give out homework. And we're going to start today's conversation with this phrase: data is the new oil. Now, this is a very provocative phrase because the concept behind this phrase is that there is finally an acknowledgement that there is value in data. For those of us who have been in this data industry for as many years as I have been, know that for the most of those years, most of that time, data was not an asset to be taken advantage of, but it was a cost to be minimized. But now we get this phrase: data is the new oil. Now, what does that mean? Well, what it means is in the same way that oil was the fuel that drove the economic growth of the 20th century, in the same way that oil was the fuel that drove that growth, data will be the catalyst that drives the economic growth in the 21st century. That it has economic value and it's going to drive growth. But there's more than to it, right? Data is a new oil, but it's much, much more. But if you believe as an organization, and I am hoping that you're here at this session because you believe that data has this kind of catalytic value to drive economic growth, if you believe that, then the single most important question you need to ask yourself, your organization needs to pose itself, is this: how effective is your organization at leveraging data and analytics to power your business models? Think about it. If you believe that data is the catalyst for the economic growth in the 21st century, then your ability to answer that question becomes imperative for your survival. Now, what happens when you ask organizations this question is most organizations have no idea how to answer that. They don't know how to compare themselves. They don't know what good looks like in this space. So what we did is we created what we call the Big Data Business Model Maturity Index. And it's a roadmap. It's a benchmark that tells you how good you could be and where you can put yourself along this path. But it also provides a roadmap for navigating, for leveraging data and analytics to become more predictive, more prescriptive, to find new areas of monetization and to digitally transform your organization. But there's some key points about this. And one of the thing gotchas here is a thing called the analytics chasm. The analytics chasm is what prevents organizations today who are very report centric. They've got BI and data warehousing and generating reports and dashboards that tell them what happened, a retrospective review of the organization, but they've struggled for years to cross over into a more predictive world, to predict what's likely to happen, to optimize and prescribe corrective actions, right? They struggle because they think the analytics chasm is a technology chasm. They think it's a technology challenge. And I'm gonna tell you right now, it's not. The single most powerful word, concept in the world of business is not technology, it's economics. And crossing that chasm is an economics challenge, not a technology challenge. It's an ability to use economics. We're going to talk a lot today about this use case by use case approach, to apply the economics of data and analytics on a use case by use case approach to become more predictive, to become more prescriptive, to monetize not the data your organization has, but the insights you have about your customers, your products, and your operations, to find those unmet needs and fill new opportunities, new channels, new consumption models, new markets, new audiences, and then eventually evolve into a digital transformation environment where you have an environment that is continuously seeking to learn and adapt, not just from an AI, machine learning, reinforcement learning perspective, but from an empowerment of the culture of your people. Digital transformation isn't just about technology. It's about how we're applying the economics of data and analytics to drive this continuously learning and adapting organization and empowering the frontline employees to be more effective, to leverage this information, be more effective. AI is not a revolution in the mahogany row. AI is a revolution at the operational level. It changes how we run our business, and it ripples back then up to the mahogany row. But anyway, if we believe this is what we could do, if we believe this is what good looks like and how we can move ourselves along this process, then the next question you need to ask is, how are we going to do this? Now, there's probably many different ways you can do this. Here's how we do it. This is our value engineering framework. And if we want to provide value to the organization, if we want to help to navigate up that big data business model maturity index, then we have to start with problems that the business stakeholders care about. We're going to call these business initiatives. And business initiatives have the advantage that they've got financial value attached to them. Improve customer retention, reduce unplanned operational downtime, improve customer cross-sell, reduce student failures as freshmen, dropouts, right? There's all kinds of business initiatives out there. And the beauty of a business initiative is there typically is dollar value attached to it, hard dollar value attached to it. We're going to start this process by focusing on what's important to the business and figuring out where and how data and analytics can help support that, help to realize that business initiative. Once you've identified that business initiative, by the way, you can't solve them all. One at a time, we're going to pick one. And then what we're going to want to do is identify the stakeholders who either impact or are impacted by that business initiative. And what we're going to want to do from those stakeholders is to capture the decisions that they're trying to make in support of that business initiative. Now, this process here is very critical. And by the way, it's detailed as a workbook in the Art of Thinking Like a Data Scientist. There are exercises, there are templates, there are design thinking panels designed to help you walk through this. But the stakeholder process is really critical. Think about a stakeholder map to make sure that everybody in the organization who is impacted by the business initiative is brought into the process. They have a chance for their voice to be heard. All ideas are worthy of consideration, because most of these projects don't fail because of a technology problem. Most of these projects fail because of passive aggressive behavior, because you've not brought all the key people into the organization and gave them a chance to understand how this business initiative, how data and analytics are going to help them be successful. And then we'd go through a process, a very detailed process to identify, validate, value, and prioritize the decisions that these stakeholders are making. It is around the decisions and how they aggregate into use cases that we bring the business stakeholders' domain expertise with the data science, technology, and analytics expertise to figure out how we're going to solve those. We focus, again, identify, validate, value, and prioritize the decisions or use cases they're going after. Organizations don't fail because of a lack of use cases. They fail because they have too many, and you haven't gotten organizational alignment around how to solve those on a roadmap, use case by use case basis. Once you've done that, by the way, everything else is easy. What analytics do I need? What data do I need? How do I instrument my IoT? What architecture, my technology? It becomes easier. Doesn't mean it's easy. It's easier because we've taken these almost impossible problems from an architecture, technology, data analytics perspective, and we put a frame around it. Guardrails, not railroad tracks. Frame around it that allows us to focus on what analytics we're going to need, what data we're going to need, what architecture, what technology, and not try to boil the ocean and solve it all. This is the death of big bang projects. Don't throw $20 million at a problem and hope it gets solved. No, you're going to go use case by use case and build out your analytic, your data, architecture, and technology capabilities. It's a whole different way to think. It's a whole new approach. And it works because you focus on generating value. And you leverage economics. And what is economics? Economics is the discipline of creating wealth and value. That's why we focus on the economics perspective. And speaking of that, let's talk about the research we did at University of San Francisco. And one of the biggest challenges I've had in my 40 years in this industry is, how do I attribute value to data? And I've struggled with this problem for decades. But at the University of San Francisco, where I'm an executive fellow, we decided to do a research project. I had access to a whole bunch of really smart research assistants that worked for free, which is a good price to have. And I set them loose on this problem. I set them loose on this problem to figure out, how do we determine the value of data? And this project was bumping along, and I was trying to figure out, how do we show data as an asset on our balance sheet? How do we make sure that the value of this company is reflected accurately by the inclusion of data? And then one of my students came up to me and said, Professor Schmarzo, this data is like a really unusual asset. I said, what do you mean? And she said, well, it never wears out, never depletes. And the same data set can be used across an unlimited number of use cases at zero marginal cost. Now, when she said that, I realized that I had the wrong frame for how I was thinking about determining the value of data. I had an accounting frame, and an accounting frame uses a value in exchange methodology to determine the value of an asset, right? What somebody's willing to pay you for that asset is what it's worth. And so the whole data monetization concept built around this idea of creating marketplaces where we could sell data. Wrong. That was the wrong frame. That was the wrong perspective. It's not a value in exchange. It's a value in use, and the ability to reuse this data across an unlimited number of use cases at a zero marginal cost kicks in this whole economic multiplier effect. The ability to reuse this data over and over again. And we can see how this works, right? Very simple example where I take a point of sales data, for example, and I'm using it in sales to improve promotional effectiveness by 2.5%. And I'm using it by marketing to improve customer acquisition by 2%. And the call center is using it to improve customer retention. And you can see that each one of these use cases, the 2.5%, the 2%, the 3.5%, each of those has economic financial value. The same data set being used over and over and over again. That was the breakthrough moment for me personally. But to do that, to experience that breakthrough moment, I had somebody to brought a whole different frame on how I wanted to look at this. They challenged my frame of perspective from an accounting to an economics, and it all became obvious. Now, as we did the research, there was a couple of dilemmas that popped up. Number one, data silos and shadow IT spend are the killers of the economic value of data. Because if you can't share it across multiple use cases, then you don't get that economic multiplier effect. We also discovered something in the research at the time I didn't give much credence to. I didn't understand it. This idea of orphaned analytics. And I'm going to talk more about orphaned analytics in a second. But orphaned analytics was a situation where we saw some of the most experienced, some of the most mature analytics organizations building analytics to solve a problem and then never reusing those analytics over again. They were so good at building analytics that they didn't bother to try to find something they'd done before. They just built everything new from scratch. We call that orphan analytics. I'm going to talk about that in a second. So what we found in our approach, and this is critical, that a use case by use case approach allows me to take the impossible task of looking at all these different data and all these analytics, and it boils down to something that's much more manageable. I now know what data I need for that use case. I now know what analytics I need. I'm not going to need all the data. I'm not going to need all 23 data sets put into a data lake before I start my process. No, I'm going to figure out which 3 I need, and I'm going to start there. And I don't need to build an analytics environment that has every kind of analytic capability in the world. No, I'm going to figure out what analytics I need for this particular use case, and I'm going to build out those analytic assets. use case by use case, ROI by ROI. It pays for itself. And let me walk you through an example of how this works. Let's say my first use case is around vendor quality. And I've determined by improving vendor quality, it's worth $60 million a year to the organization. Maybe it's $6 million, whatever it is. But if I can solve that problem, let's say that I need 3 data sets to solve this problem, which by the way, you're going to find out as you go through this process, you don't need 20 different data sets to solve problems. You're going to find that 3 to 4 to 5 data sorts are the ones that are most relevant. In this case here, there are 3 data sets I need to solve this vendor quality problem and 2 analytic modules, maybe an analytic module on anomaly detection and an analytic module on vendor quality scoring, right? That's A and that's B. What I can do is I can attribute the value of that use case down to the data sets and to analytic assets. Now, I just use a straight line. You want to get really fancy, you can use random forest or PCA, but let's be honest. Let's just be simple. If it's worth $60 million, I got 3 data sets. They all get credit for 20 million. And those 2 analytic assets delivering 60 million, they get $30 million credit each. All right, now I got a process for figuring out how I attribute value down to my data sets. And then I start going through this use case by use case. Excuse me, pause. Dramatic effect. My second use case is around vendor reliability. Worth $30 million. Here's where it gets interesting. I'm going to reuse data set A, but I need to add a new data set D. I'm not going to use B and C. So I've got 2 data sets, A and D, that I need in order to improve this vendor, to create a vendor reliability score. And I'm going to attribute to those 2 data sets 15 million each. Now A all of a sudden has gotten 20 plus 15. It's now attributed $35 million of value, right? And D's got 15. And same thing with analytic modules. I'm going to reuse the anomaly detection, number A, but I'm going to build a new one to create a vendor reliability score. But I can attribute value, 15 to each, and now again, we're seeing A start to accumulate. And so what happens here, I think you can see the process. Use case by use case, I'm building out my data assets. I'm building out my analytic assets. I'm building out my data lake. Every one of these use cases has a positive ROI. You're printing money and you're building out your data assets and your analytic assets at the same time. And you're able to attribute value. All of a sudden, we're starting to realize how valuable data set A is. If I'm going to invest money in data governance, in metadata management, in data enrichment, data quality, by golly, I'm going to start with data set A because it's the most valuable. Not all data sets are of equal value. We don't have a process for how we determine that. And so most data governance efforts, most metadata management efforts die on the rocks because we don't know where to prioritize. Here we do. Now we have a process for prioritizing use case by use case, build out our data lake use case by use case, and analytic assets use case by use case. But let me give you one little observation here. By the virtue of reusing the analytic assets, you avoid this orphan analytics problem. And any enhancements you make to those analytic modules ripple back. For example, if one of your giant big brain data scientists figures out how to use hyperparameter optimization and some data engineering and feature engineering and figures out how to improve the performance of that module A, the anomaly detection module, by 1%, they made it 1% more effective. That impact ripples back to each of the other use cases that use that module, and each of the other use cases just became 1% more effective at a marginal cost equal to 0. Think about the power of this. And in fact, I'm going to skip through this in a second because you can see, by the way, how this use case by use case process is going to build out your data lakes and to build out your analytic assets. But this whole idea of the ripple effect of how I can create assets, analytic assets, and improve them. When I don't have orphaned analytics, but I have composable, reusable assets, analytic assets, how that impacts the organization. And let me bring this to really a conclusion that talks about how you leverage analytic assets and create analytic assets that actually appreciate in value, not depreciate in value as they're used. Now think about this. In accounting, when you have an asset, when you buy an asset, you immediately start depreciating its value. I'm going to challenge you with a statement from Elon Musk. I love this challenge by Elon Musk. And this is really, the title of the slide should really be, in order to change the game, change your frame. And here's the key point here. I love this quote. He says, if you buy a Tesla today, I believe you're buying an appreciating, not a depreciating asset. Think about that for a second. What does he mean by that? Well, some people thought that he was saying that if you bought a Tesla because of its uniqueness, it would become an instant classic. And if you stuck it in the garage, in 10 years, it'd be worth more. No, it's not what he said at all. He says that the more you use this car, the more valuable it becomes. The more you use this car, its value appreciates. That runs totally counter to any sort of accounting perspective, but it runs smack dab into the heart of what makes economics powerful. Let me talk to you about how your organization could embrace this game-changing perspective from Elon Musk about how you can build analytic assets that appreciate in value the more you use them, not depreciate. Let's walk through how that happens. And the heart of this entire process is artificial intelligence. It's an AI agent. And this is, I'm not going to spend a lot of time talking about AI because there are much brighter people in the world to talk about this, but this is how it works. An AI agent looks at the environment it's in. It looks at everything it's learned. It takes evaluation of the state it's in, and it takes an action. It makes a decision. It then sees what that decision does, sees what the impact is, what's the reward or penalty from it, and it creates a new state. And every time it takes an action, it's learning. And by the way, its actions are guided by what's called the AI utility function. The utility function measures. It's a large number of variables and metrics against which the AI agent's going to measure progress and success, right? And we could spend a whole day talking about the importance of the AI agent and how it has to look at not just financial aspects and operational aspects and customer aspects, but a good AI agent also looks at environmental aspects, it looks at cultural aspects, and I'll tell you at the very heart, it looks at spiritual aspects. And if you don't understand what I mean by that, for example, there's a huge difference between do no harm and do good. And if you're confused about the difference between do no harm and do good, pick up the Bible and read the story of the parable of the Good Samaritan. So the AI utility function, the craft of the AI utility function is very critical. Not a throwaway task, not something a data scientist does. It requires lots of thought, but that AI utility function then guides this continuous learning process where every interaction this AI agent's having with its environment is changing its state and it's learning through each one of these things. So think about Elon Musk again, right? Elon Musk has these cars. It has an analytic asset in it called a FSD, fully self-driving module. It's a module that's continuously learning. Every car has this, and the Tesla is basically one big giant IoT platform, and it's got edge analytics across all the different places, the tires, the transmissions, and the climate control. This car is wired to the wazoo. It's one big giant IoT engine, and sitting inside of this thing is an AI agent that's continuously learning. Every time that car turns a corner, it learns. Every time that car passes a pedestrian, it learns. Every time it's raining and it has to navigate a puddle, it's learning. So this car is continuously learning. By every action it takes, every engagement it takes, it's learning. And then every night, brilliantly, all of these now 500,000 Tesla cars take what they learn, they push it back to a simulator in the sky where the Tesla is massively reviewing and taking in all this learning. It's simulating all these, and at the end, it's back propagating those learnings back to the cars. Those cars are continuously getting more effective, more reliable, more efficient, more safe, right? More predictive. The cars are improving. And it may only be by 1%. Maybe it's only a 1% improvement, but we know that the law, the economics of compounding work to your advantage. That a 1% improvement, for example, improved 365 times equals a 37-point-X improvement. The power of compounding and the ability to continuously learn, it's a new game. Elon Musk is playing a different game than everybody else. It requires us to think differently about how we build out our data and analytics. And it isn't a technology conversation. It's how do I exploit the economics of data and analytics? So let me conclude with some key points here. Point number one, I'm going to argue that the economies of learning in knowledge-based industries are more powerful than economies of scale. That the companies that are going to win in the 21st century are the companies that learn not only from their data and analytics how to become more efficient, more reliable, more predictive, more safe on a continuous 1% basis, but they're also empowering their frontline employees to also continuously learn. that they are at the point, the intersection between the economies of learning powered by AI devices and the power of learning powered by human devices. And so this ability for the economies of learning and to learn more quickly, to learn and adapt more quickly in your competition, that's the new battleground. Elon Musk's figured that out. No one else has. And so what does this mean? This translates into a theorem. This is called the Schmarzo Economic Digital Asset Valuation Theorem. This is my bid to get a Nobel Prize. And by the way, my upcoming book that I'm working on details this in great detail, right? We go into a lot of detail about this concept, but there are three effects that are enabling organizations by how I take a use case by use case approach to build out my data and my analytic assets. Use case effect number one is my marginal costs flatten. At some point in time, as I'm going use case by use case, I've got all the data that I need, which by the way, isn't all the data that I have. Organizations are soon going to realize that the valuable data, amount of valuable data they have, isn't all the data. That some data sets are incredibly valuable and some probably have no value at all. And maybe because of liability reasons, you might even want to get rid of them. Right? There's a controversial thought for you, but at some point in time, my data lake now has all the key data sets I need. So I can go use case by use case. And I'm reusing my analytic modules over and over. So I'm driving down or flattening my marginal costs. But while I'm doing that, that reuse of my data and analytics also kicks in effect number two, which is how my economic value accelerates. Because I'm reusing my data and analytics on a use case by use case basis, I'm shrinking time to value and I'm de-risking the projects, right? I'm basically becoming much more efficient. I've learned and I'm starting to master the economies of learning use case by use case. I'm applying the learnings that I've gotten from use case one and use case two, and I'm applying to three and three to four. So I'm constantly getting faster and better at this thing. But here's the game changer. This is the Elon Musk effect. This is the Google TensorFlow effect, right? Google TensorFlow effect. What do I mean by that? Well, think about TensorFlow for a second. TensorFlow, the Google's machine learning, deep learning AI framework, powers Google's business, including their search business. The single most profitable business in the world is Google Search. And they power it through a product called TensorFlow. And what does Google do with that very valuable asset? They open source it. They open source it. The single most invaluable asset they have, they open source it. They give it to everybody to use. Why would they ever do that? Why in God's green earth would they ever do that? And here's what Google knows that not everybody else knows, is that everybody who's using TensorFlow across a wide variety of use cases is making TensorFlow smarter, more reliable, more accurate, more predictable. Yeah, they stole the page from Elon Musk, or Elon Musk stole the page from them, but they're basically betting that everybody out there who's using TensorFlow is helping them become more efficient in their business. Everybody who's using TensorFlow is helping make Google search even more effective. And what that means is that this ripple effect, that this 1% compound improvement, that every kind of change I make to my analytic module to improve it, every other use case that used that module just got 1% better. And it ripples through to the fact that now I have these analytic modules, a small number, a manageable number that I'm constantly investing in. This is the FSD module for Tesla, right? That I'm constantly making that better and better. This is a game-changing concept. Google and TensorFlow are playing a different game. They're playing a game that's based on learning faster than the competition. So let me wrap up with these mandates. This is what I think you should take away from this session. And this, by the way, is the focus of my fourth book. I think it's time we all need to take a page out of the Elon Musk and Google books, right? And understand more about it. For example, number one, economics is the most powerful force in business, not technology. I don't want to drain these all. You're going to get a copy of this. Number 7, a use case by use case approach exploits the economy of learning, which basically is point number 5. The economies of learning are more powerful than the economies of scale. And in knowledge-based industries, this is especially true. And by the way, every industry is a knowledge-based industry, right? Number 2, if data is a new oil, then the single most important question our organization needs to ask is how effective are we at leveraging data and analytics to power our business model? Point number 8, AI and the ability to continuously learn can create assets that appreciate in value, not depreciate through usage. And of course, number 0, which I couldn't put a 10 in because it would explode it, is that Schmarzo's digital economic valuation theorem is a game changer. And if anybody deserves a Nobel Prize in economics, it's me. Anyway, thanks for your time. I believe we're going to have some Q&A. Steve's going to help moderate this. I see a bunch of Q&A stuff has come in. So remember, the more questions you enter, the better you chance have of winning that book, that blue book, Data Thinking Like a Data Scientist, which is an ebook, by the way. Steve, up to you.
All right, thanks, Bill. Great presentation. Yeah, I've been monitoring the questions and the comments coming in, and they're really good. It started off kind of talking a little bit about using the data as the new oil, and kind of that's getting a little bit long in the tooth for some of the comments. But also there was a lot of talk about the analogies that spurs. One of them was around, which I thought was really interesting, kind of looking at oil coming from tar sands, right, where you're mining and baking the oil out of sand. A lot of data needs to be reconditioned to and extracted basically to bring the value out of it.
Steve, that's a really good. Steve, that's a good point, by the way. We don't just take raw data and analyze it. Data has to go through a curation process, much like oil, right? We don't see cars running around the streets with barrels of oil on their trunk, right? Oils go through a curation process, and data has to do the same thing. You got to cleanse it, you got to align it, you got to normalize it, you got to enrich it, you got to there's all kinds of things you need to do to make sure that data isn't raw data, but is actually curated data. And by the way, your data lake, I think, Steve, as part of that, your data lake takes on 2 different dimensions. There's a component of your data lake that's like a sandbox where the data science team is trying to figure out what value there is in the data for the use cases we're going after. But after you figured out that there's value in data, it goes into this curated, published data lake where these are data sets that have been curated, blessed, validated, enriched. So I think that analogy is spot on, that it isn't just data we want. And that's, by the way, what also makes a data engineer such an important player in this space. The data engineer is chartered. And the whole idea behind data ops is to take that raw data and to turn it into something very valuable.
Mm-hmm. Yep, no, that's a good point. The thing that the audience really likes, I think, is the analogies of economic essence, basically analysis to data. And one of the questions here is around this area. So the question is, can we apply economic analysis to all information technology, not just for data to decision value chains, and where does this lead? How would you address that?
I actually think that's a very, very smart question. I think economics is a underutilized tool for most organizations, and economic perspective is different than financial perspectives. An economic perspective is, how do I take an asset and create value from it? It's like why a car is more valuable to an Uber driver than it is to me, right? Same car, but that Uber driver is using that car to generate value. So to me, I think that's a very provocative, because the question becomes, how am I using technologies and my architecture and stuff to create value? And in particular, the challenge I'd love to I got to give more thought to this, is the whole economic multiplier effect around data and analytics is so powerful, because they're digital assets, they never wear out, never deplete. So I can apply this economic multiplier effect and see that kind of explosive growth. I wonder if I can do the same thing with like applications, digital applications that are continuously learning and getting smarter. An architecture that's continuously learning and getting smarter. So I would say that taking an economics frame, in particular the economic multiplier effect, and figuring out how you can reuse assets over and over again at a near zero marginal cost, that's the point where you change the game.
Mm-hmm. Good point. Good point. Another question here, it kind of deals with small and medium-sized businesses. Do they need to hire a data and analytics expert? Is it required? And how do they evaluate third-party resources if they don't have a person to do that?
So that's another good question. So I think small and medium-sized businesses have a huge advantage over large organizations in this conversation. And the reason why is that these initiatives don't fail usually because of technology. They fail because of culture. And it's really hard in a big organization to get everybody to agree on what use case to focus in on, and here's our roadmap of use cases and how they're going to play out. But a small organization, especially, I've been involved with several small organizations who got it very quickly and were able to corral the business stakeholders to teach them how to think like a data scientist, and then how to work with the data scientists themselves. The key to data science success isn't on just hiring the best, most brilliant, most expensive data scientists you can get. A really key component is how do you get your business stakeholders who have all this domain knowledge about what's going on? How do you bring them into the game? Which is why the art of thinking like a data scientist was not written for data scientists, though a lot of universities use it. It was really written for business stakeholders, for them to think about, what do I need to do? How do I need to change my frame about the business in order to better figure out how I leverage data and analytics and data science to drive that? So, to really long-winded answer, I'm always full of long-winded answers. I think small and medium-sized organizations have a huge advantage because they can move more quickly. They can get the business stakeholders lined up and can move quickly. And then once you've done that, yes, you've got to bring on board either through third party or however you want to do it, consultants or data scientists who can do that work for you. But I would also challenge you, this is the point now where you run into this orphaned analytics problem, that you want to make sure you're building your analytics for composability, reusability, and scalability, not one-off. When you're only using your analytics one at a time, yeah, you get that sort of Krispy Kreme donut sugar rush, which is great for one time, but I want more than a sugar rush. I want to dominate the world.
Great point, Bill. Here's something that really hits nerves with people, and it came up actually yesterday too in several of the sessions. It's around kind of ownership and how to approach data analytics. So the writer or the reader looks. They agree with the data is the catalyst to economic growth, but in the real world, the senior leadership team thinks that the technology guys own this. As you stated how can you bring all the stakeholders together? Ops, HR, finance, key accounts, etc. How do you really get effective collaboration going across these groups? Because it shouldn't just be an IT thing, right?
God, no. In fact, that's why these things fail. The business washes their hands, or Pontius Pilate there, and they wash their hands of it, and they say, IT, it's your problem. You're the one who got all the data, but the IT group isn't the one who can figure out how to monetize that. The business stakeholders have to take ownership, which is why that in that value engineering slide, I talked about, first off, you have to pick a problem that the business cares about. For example, if I'm dealing with a company, it's a public company, I go to the annual report, I read the president's letter, and they're talking about something like, we got to improve customer retention, we need to improve quality of products, we need to reduce unplanned operate. They say that in the annual report, that's a problem I want to go after, because it's not an IT problem. IT can do what it needs to do. It's a business problem. So that value engineering process where you start with a problem that people care about, that has significant financial value, right? And I'm talking, 10, 50, $100 million in value. I want to start there. And then you want to bring all those stakeholders into the process. Business stakeholders, sales, marketing, finance, operations, logistics, right? Procurement. You bring them in and you make sure that their voice is heard. You go, and the key for us has always been around decisions. We want to identify the decisions those stakeholders need to make in support of that business initiative at the top. And here's the beauty about decisions. Every stakeholder I have ever talked to in my 40 years in this industry knows what decision they're trying to make. They've been trying to make them for years. Who are my most valuable customers? How much inventory I need to order? What should I plan for production in corn this year, right? They're trying to make these decisions. They've been trying to make them for years. They instinctively know what decisions are important to them. They have good ideas around those. They've been making decisions. The decisions haven't changed. What's changed by virtue of the data and the analytics are the answers. And so if you bring in that value engineering process the business stakeholders and you help them think like a data scientist, and the light bulb goes off and they go, oh my gosh, if you could tell me this, I could do that. If the data could tell me which of my customers are most at risk, or which of my assets are most likely to break down, or whatever the problem might be, when they hit that light bulb moment, then they're the ones pulling IT instead of IT trying to push the rope.
Mm-hmm. Great point. Great point.
Good questions. By the way, Steve, I want to make sure I get all the questions. For the ones I don't get to, these are good questions.
Yeah, well, I think what we'll do is we'll go ahead and capture all the questions and we'll create a blog about it.
Sure.
And publish that for everybody to see. There's one more question maybe you could take. We have 1 more minute left. Do you think data should be logged by accounting as money is logged and saved?
No. So here's, and I said that way too fast, and here's the reason why I do that. I have been in too many arguments with people who think about data as an accounting asset, that the fact that you have it is of value. Bullshit, right? And in fact, a really good friend of mine just published something that he uses a measure that he thinks measures the value of data by how much somebody uses it, how much somebody touches it. That doesn't create value. I can run around the house and touch all kinds of crap, right? No, the value in data comes from how you use it and what problems you're trying to solve with it. So I resist this accounting concept altogether because I think it pulls us into the wrong track. It gets the wrong people focused on it. Forget the accounting approach. All you accountants can hate me. You can throw, tomatoes at me. No, let's focus on an economics, and the value we're going to generate that's going to be reflected in the balance sheet and income statement are increasing revenues and improving margins and profits. That's what it should do. Again, data is not a value in exchange valuation methodology. We shouldn't use a value in exchange. We should use a value in use and how we are using data, not how much data we have, but how we're using it to actually drive value around the organization's key business initiatives.
Mm-hmm. Great, Bill. Hey, we've been granted a little more time from Lucian here. If you're ready for a few more questions.
Sure, yeah, we'll keep going. This is great. I got my Starbucks, so I'm in good shape. I just keep going.
Okay, great. Next question: how do you make sure that the collected data is not defective and that the tolerance for the data is to be used is taken into account?
That's a really good question. So there's this phrase out there, separating signal from noise. And what it means is that the fact that you have data doesn't mean anything if you don't know how you're going to use it. That once you know how you're going to use it, then you can figure out in the data what is signal and what is noise. And so the question here, I think, is about when you understand what about the data is important and what's not, that you now have a vehicle for driving all your governance and metadata enhancements process. You really have allowed the IT organization to have a laser focus on prioritizing their investments around data and analytics. But it requires that sort of, I think as the question mentioned, is that whole idea of how you're going to use it. And again, if you don't know how you're going to use it, then it's hard to figure out what's valuable in data. And again, data is full of all kinds of stuff. There's a lot of stuff in data that may or may not be useful. If you don't know what's valuable in data, then you don't know where to focus. And this is kind of the heart of the data ops challenge, right? Data ops can fix a lot of problems, but you better know what problems you're trying to fix first. And if you don't know how you're going to use that data to drive value, then how do you know what problems you're trying to fix? And how do you properly optimize your data ops investments?
Great, great. So a lot of people are really interested in getting involved with more data science. So how is an engineer with a software background get started with data science without spending too much time in theory?
Oh boy, hard question. And there's a lot of incredibly valuable free sites out there where you can take classes online to learn more and more. What I would suggest is that if you're trying to learn more about data science, focus initially on understanding what you can do with it, not how it works. For example, you can spend a lot of time trying to figure out how to write a convoluted neural network, a CNN, right? And you can actually, there's classes that walk you through how to do that and shows you all the techniques for it. And there's a lot of great classes. But I would start first by understanding, well, what would I use that problem for? What is that problem really good for? And if you start with that, how am I going to use it perspective, then I think as you start getting into the mechanics of it, you'll realize that, well, some of these mechanics aren't as important as others, because I'm concerned about how I'm using it this way. So I think that there's a lot of source. Coursera's got a bunch of sources, and there's a bunch of online classes. We offer at Hitachi Vantara, we have a class called, I think it's called the Adaptive Data Scientist, which starts off, by the way, with a whole section out of my book, because I think it's important to get both business users and data scientists to think like a data scientist. And once you have that frame of how you're going to use data science, and I think when you start diving into the details of difference between reinforcement learning and supervised and unsupervised machine learning, now you're starting to figure out what I can do with these, which then helps you figure out what I need to do from a data science perspective.
Mm-hmm. Great, great. Here's a good chicken and the egg question. Should one start with use cases and look for data sets that would enable value creation, or should they start by selecting and curating data and then finding use cases where economic value can be created?
So I will first say that there's probably many different ways to solve this problem. I firmly believe start with the use case and then bring in the stakeholders and brainstorm what data they might want in order to solve that problem. Now, the power of the word might, that's a powerful word. And what we find is that if you think about what data science is, you don't have to buy a 600-page book to understand what data science is. Here's what data science is all about. One sentence. Data science is about identifying those variables and metrics that might be better predictors of performance. Might. And so what I want to do is I want to start with the problem first and then brainstorm what variables, metrics we might need, what data we might need. And we're going to find that we've got some of that data. We don't have some of the data, but now I can figure out a process for figuring out, well, I want to look at this data because I think this data might help solve this. This is the power of bringing the business stakeholders and the data scientists together in doing this brainstorming process. So the value engineering process that we embrace, and I talk about in my books, always starts with a use case. And I like starting with use cases because of one simple fact. Show me the money, right? I like to say that, big data is not about the three V's, volume, variety, and velocity. No CEO or executive I've talked to gives a crap about the three V's of big data. What they care about are the four M's of big data. We're going to end with this. The four M's of big data. Make me more money. So I like starting with use cases because that feeds right into the four M's of big data.
Yep, that's a good point. That's a great point. There's jobs today that exist that nobody even would have dreamed would exist today 10 years ago. So what kind of new enterprise or economic activity is going to come about with the valuation of data becoming the norm, hopefully in the near future?
So the one skill set, I'm going to kind of take the question off on a little bit of a tangent here. The one skill set that I teach to all my students that I think is underappreciated is design thinking. Because I actually believe that AI is going to force humans to become more human. That AI is going to start taking on more and more of the mundane tasks. And our ability as humans to empathize with compassion, to ideate, to have creativity, to have curiosity are going to become more and more important. That I think the people in the next generation, all the students I work with, I talk about the power of creativity, the power of curiosity, and how that drives innovation. So to me, design thinking, and by the way, all my data scientist team has been trained on design thinking. I have a design thinking guru on my staff whose job is to make sure that all my data scientists, my data engineers understand about design thinking because it helps them to understand and empathize with what's going on with the customers, to ideate. Design thinking is all about trying different things, prototyping, failing, and learning. Well, that's exactly what data science is. And so I think going forward, I think design thinking becomes this very indispensable skill set that we're all going to need to learn how to master, because AI is going to start taking over more and more tasks. But they're tasks I don't care about. If they're doing tasks that I don't want to, want me to recognize license plates, snore, right? I gave up trying to calculate square root when I bought a calculator. How many people today calculate a square root of 37 in your head? No, you grab a calculator, push some buttons, and you're done, right? As humans, we have a chance to move beyond just being held captive by technology, but actually leveraging what makes humans human and our ability to drive curiosity and to drive creativity. So again, I'm a huge fan of design thinking. Not only do I talk about it, but we live it in how we run our operations.
Great, great. And one last question here. This is basically around the business owners, the people in your organization that have responsibility for certain portions of the business. What's your recommendation on how to get these business folks to get out of their comfort zone of business instinct and making decisions based on that to more data-driven insights?
Great question. So there's two things. First off, you want to leverage those instincts. If they have instincts, a lot of these business stakeholders, as I said before, they've been making these decisions for a long time, and they've created heuristics and instincts to help them make those decisions. Start there. Take those instincts, take what they have, and apply data science to figure out, well, were their instincts right or not? Are there things about it or are there things or aspects about it that are right or wrong? Bring those instincts in. Our data science projects always start by trying to capture the heuristics people are making today. One of the favorite things I love to get in one of these projects is a customer who's trying to make decisions and they got an Excel spreadsheet. Wow. I mean, that's not big data, trust me, right? But what are you trying to do? What variables are we looking at? And from that, we're going to start getting ideas about what we might be able to do to actually employ data science. So my advocacy is bring this instincts into the process on day one. And then number two, focus on creating a proof of value. Right? Don't operationalize on day one. Don't try to build this thing out on day one. Instead, take on a small 12-week proof of value project where you actually take the data and this person's instincts and you're starting to figure out how do we improve those instincts? How do we actually prove them and improve them? And you may find in many cases, a lot of heuristics are outdated, right? Like my dad said, change your car, oil in your car every 3,000 miles. Well, Dad, I got an electric car. That's not going to really make any difference, right? So rules and heuristics change, but start there first. Not only is it a great starting point to accelerate your data science process, but more importantly, you bring these business stakeholders into the tent with you to help solve those problems.
Great, thanks, Bill. It's been a real pleasure hearing you speak. And also thanks to everybody in the audience for your questions and your comments. We're going to go ahead and put together some written answers that we'll share in a blog for everyone here. And now I'd like to return it back over to Lucian.
Thank you, Steve, and thank you, Bill, for a very engaging session. And now what I'd like to do is share the screen of Dr. Rodinsky, who will draw the lucky winner. There are over 40 questions, so about 42. And we took all those names, put them in the wheel of names.
We have a winner.
So the winner will get the ebook. Thank you all for joining. Thank you for the exciting session, and stick around. There are a couple of tracks that you may want to join. The open source one, there's Innovation in Action and Industrial IoT with another speaker from Hitachi Vantara. Look forward to seeing you all in the rest of the day. So thank you for supporting. Thank you, Hitachi Vantara, for sponsoring this keynote.